Okay. So our first, the last one. Are we talking about the homework, guys? Are we talking about the question in the? Okay. So let's look at the homework. Sorry, I'm just pulling it up right now. So I may have different numbers than all of you, but let me just see. Oh, yeah, okay. Let's look at this. So this is homework number 4. Number 25. So this is the last question. And yeah, this is a good one to go over, definitely. So it says we have a function, right? We have f of x. This equals x minus 4 over x plus 4. Okay, and then it's asking us find the inverse function. Find the inverse function f inverse of x. So we want to find it. Now remember what we have to do first. Well, first of all, f of x, we're just going to write it as y. So we got y equals x minus 4 over x plus 4, right? So all we did here was just made f of x equal to y, and we can perfectly do that. Then the next step is to what? What's the next step? When we want to find the inverse function. So once we have this set up here, what do? We switch the, very good, Andrew. We switch the x and the y. So we swap, let me write this in blue here. So let's swap x and y. Now, what does that mean? That means that wherever I see a y, make it into an x. And wherever I see an x, write it as a y. So this will look like this. X is equal to y minus 4 over y plus 4. Okay, so that's what we have to do. And now after we swap the x and the y, what is it that we try to do? We solve for y. So that's the extent of defining the x and y. And when we do this algebraically, that's really what we're doing. We're just swapping x and y and solving for y. So now at this point here, we are looking at how to solve for y and doing so algebraically speaking. Now remember, when we say we want to solve for y, what is it that we're trying to do? We're trying to isolate y. I want to get y by itself. What's the problem? I got y in the numerator and I got y in the denominator. Remember, we cannot cancel anything out because of this minus and this plus. We can't do that. So what is the only thing that I could do at this point in time? Well, what I'm going to do is I'm going to multiply both sides by y plus 4. Now, why is it that I'm going to do that? If I multiply by y plus 4, the y plus 4's here cancel out and become 1, right? They cancel out. And what's on the left side? It's going to be y plus 4 multiplied by x, and this equals y minus 4. So do you see why I did this? Now, all of the y's, you can think of it. At first, y was in the numerator and in the denominator. Now all the y's are in the same playing field. They're on the same level. They're in the numerator, per se. But the problem is I have y's on both sides of the equation, and I only want them to be on one side of the equation. So I still have to get all the y's on the same side. They were on the same side, but they were on different levels. Now I want them on the same side and to be on the same level. So what I should do now is I should distribute the x, and I get xy plus 4x equals y minus 4. Now, what is it that I want for? I want to get y's by itself. Again, the y's are on two different sides of the equation, so that I should make them the same. And how do I do that? I need to subtract the 4x on both sides, and I need to subtract the y's on both sides. So the 4x's here cancel, the y's here cancel, and then I get xy minus y equals negative 4 minus 4x. And now look what I have. I have all the y's on the same side of my equation, but I still want to get just all of them bunched up together. I want to combine. I want to get y and just one y, not xy minus y. So in order to do so, I must factor out the y's. So let me factor out y, because I can do that. And when I do that, what's left? X minus 1, and that's minus 4 minus 4x. And we're almost done. So you see what this accomplished? Factoring out the y, it now only have one y to take care of. So then when I divide out the x minus 1, and then I get y is equal to negative 4 minus 4x all over x minus 1, or I write it as f inverse of x is equal to negative 4 minus 4x all over x minus 1. And of course, you all may have different numbers. Maybe you might have x minus 5 over x plus 5, but it doesn't really matter what you have. The steps here are exactly the same. So any questions about this last problem? It's a good problem to go over because the crux of this problem is understanding how to solve for y using algebra. So is this clearer now? Yes, good. Very good. Okay, then Chen asks for number 7. So if we're good with this, we can go on to number 7. Can the negative 4 minus 4x be factored? Of course. Of course. You can write this if you'd like, right? So at this point, we found the inverse function, so we found it. We're done. But if you want to rewrite it, which you totally can, you can factor out a negative 4 if you'd like, and this becomes 1 plus x over x minus 1. But at that point, it doesn't really add anything. It doesn't really give you anything that you would need. So yeah, when you factor it, there's not much that's done after that. So you could factor it. Sometimes you see that you can factor things or simplify things, but it's not necessary. At this point, not necessary, but you could. Okay? So really the crux of this problem is understanding this whole process here. And this is algebra. This is not even like anything that has to do with in terms of pre-calculus. This is really just algebra. The whole process of finding the inverse function, that's the pre-calculus topic. But this portion here, which is the crux of this problem, is just really algebra. Okay? Okay, so that's number 25. So and there's no other questions, then let's move on to number 7 from the same assignment. And let me draw out what I have. It might be very similar to yours. It might be different. So I have a parabola. Boom. So this parabola here represents the parent function y equals x squared. And then I have another parabola. Looks like this. And the important thing to note, it says that f and g are given. Find a formula for the function of g. Okay, I see. So I think there might be maybe a confusion as to, I think there should have been more said to this problem. The problem is saying, let me write this as f. So this is f of x, and this is my parent function. Remember we talked about parent functions? This is one of them. And what we're doing is we're transforming it to a new function called a g of x. And now the question is, what is g of x? And g of x is a transformation of f of x. And all we have really is that the point here, the maximum point here, this is the same as the minimum point here. It's the same point. It's just moved throughout the xy axis, the xy plane. So if you notice, how do I get from here to here? That's one way you can think about it, right? So Chen says we reflect across the x-axis. Good. Move it to the right and then move it to, yeah, exactly. That's exactly right. So we move how much to the right? We move 3, right? And then we move up 2. Yes, Chen. So I wonder what happened, because what you said is exactly right. So what are the transformations? So let me write it this way. So my parent function is y equals x squared. Or I should just write it as f of x. I don't know why I keep on saying y. So this is my parent function. And then the transformations that I apply. What are the transformations? So one thing I can do is I can flip this first. You see how this is opening upward, this is opening downward? So it would make sense that I would have to flip it somehow. And how do I flip it or reflect it? I reflect across the x-axis. And what's the corresponding transformations? Chen, it's okay. You don't have to share your screen. I think we can take care of your situation, but let me just go get through this real quick. And then reflect across the x-axis. This means that I'm going to do what? This will be f negative, right? Negative f of x. I'm gonna put the negative right outside. Then I'm gonna shift it over horizontally. So horizontal shift to the right 3 units. So what does that mean? This will be negative f of x minus 3, right? Because I shift to the right by 3 units, so I subtract the x inside by 3. And then lastly, I vertically shift up. So vertical shift up by 2 units. So then what is that going to look like? That's going to look like my new function, g of x, but it's going to be negative f of x minus 3 plus 2, right? So, Chen, is that what you got? Something like this at the end? No? Okay, so that could be the problem. Now, that's not gonna be the answer that you're gonna plug in. Yeah, it should be plus 2. Oh, I think that's what so you did instead of minus 3, you did plus 3. That's the problem. Plus 3 means you move to the left, but you just told me you move to the right. So when you do to the right, remember you subtract. You don't add. That's like the opposite of what we would think or what we would expect. We would expect that if you add by 3 inside the x, you would move it to the right, but it's the opposite. Now, what we're going to plug into the actual box there is not this graph. It's not this exactly. Because what is f of x? Remember, what is f of x? F of x is our parent function. So the final answer for g of x will be negative parentheses. Parentheses what? The parentheses what we have inside is x minus 3. And what am I doing to x minus 3 in terms of my function f? Well, I'm squaring it. I'm squaring it. And then I'm adding plus 2. And so this is the final answer. Does everybody follow this? So we were able to identify our parent function. We were able to identify the transformations that are applied to our parent function to get our final function here. And then all we had to do was, given the transformations, apply the commands, algebraic commands that we spoke about, and then put it all into one single function. And there we have it at the end. So is this clear? Is there any other issues with number 7 or any other question on the homework or anything from any quiz? And again, we have the review sheet up. So if you want to look at the review sheet and see anything that on the review sheet that you would like to go over, this is the time to do so. So think of it as a problem session time, as a question time. So it says 19. The negative f of x represents the reflection. Yes, of course. That's why I'm associating it, right? Reflect across the x-axis. Negative, put a negative in front of the function. Okay, and then it says use not. So let's look at number 19. I think we have some people from 19. Okay. So number 19. Oh, yeah. So number 19 is a composition of functions of question. Remember, we talked about composition of functions and how one affects the other. How it's a sequence of functions being applied. So here we have a big function. We call it g of x. And it has this x squared. You might have different numbers, but it doesn't really affect the core of this problem. So we have this function g of x, big G of x, is x squared over x squared plus 6. And so basically what they're asking us for is to rewrite, right? Rewrite our function as a composition of two functions, as f of g of x. All right, and we can also write this notation, f follows g of x, right? So basically they're asking us, what is our inner function and what is our outer function? Remember that? So what is our inner? What is our inner function? And in this case, our inner function is g of x. And what is our outer function? F of x. So we don't know what this is, and we want to figure out what this is. Okay? So how do we approach this? We have to look at what this function is and observe this a bit more, study this a bit more, and then see how can I make this one single function into a composition of two different functions. And remember what I told you? This kind of decomposition into two different functions is not unique, meaning that there could be more than one way of decomposing it. But for this problem, I only see one clear way. Now, if you notice this, right? If you notice this function, what do we have in common here? We have an x squared and an x squared. So wouldn't it make sense to to find a way? In a way, we've noticed that this function, the inner function, could be considered as x squared. What if we make our inner function x squared? And then what would be our outer function? Our outer function would be x over x plus 6. Does everybody see this? Because why does this work? Because let's apply f of g of x. Remember, what's our inner function? It's x squared. And remember what this means now? This means that wherever I see an x, I'm now going to plug in, instead of just x, I'm going to plug in x squared. And so therefore, I get exactly what I want. X squared over x squared plus 6. And this is g of x. Does everyone see that? It's kind of like, it is a different kind of question than what you're normally used to, probably, because you have to see how can I rewrite this so that when I plug in one function into the other function, I get the final form. This is what I expect. So what would we put as the answer? It says it wants it as a, I don't know why it wants it like in this form, but it wants it as a comma separated list. So on the actual WebAssign, the answer is in the form of parentheses f function. The f function here would be what? Yeah, the f function would be x over x plus 6, comma, and this will be the g of x function, which will be x squared. So remember, this here is the f of x function, and this here would be the g of x function. So that's how you would write it in the homework. That's how they want it. But again, the answers are these two functions. That's the answer. This and this. Why are they the answer? Because when I apply f of g of x, I get exactly g of x. That's the whole point. Yeah, Natalia, in this problem, the word is decomposing them. We're decomposing our function into two functions that if I were to compose them together, I would get what I started with. We did something like this. We did only one example, but there's many functions that can be rewritten as a composition of two functions. So if you want, we can do number 18 and then hopefully start to see the major idea behind it. A lot of this is about recognizing patterns. This type of question will be on the exam. So to give you a better understanding of what will be on the exam, it really is about looking at the topics on the review sheet. So if you look at the review sheet number 1, and in terms of composition of functions, right? In terms of composition of functions, it's mostly a question like number 18 or 19 is not going to be exactly on the exam, but it is good to understand how to do this particular kind of composition of functions. Okay? Because this will come up again, especially when we talk about calculus and doing derivatives and applying the chain rule. This is going to appear again and again and again. So let me just do 18, and hopefully it's a little better understood now. So 18 is the same idea, right? We have a big function, f of x, and this is parentheses x minus 6 cubed. Now, what we want to do is I want to write an inner function and an outer function. So my inner function is f of x, and my outer function is g of x. Hopefully this should not take too long, because the inner function, remember I've mentioned this, the inner function is the expression inside the parentheses or inside the radical. So it's kind of almost like lends itself to say that the inner function would be x minus 6. So usually finding the inner function is the easier part, and then I think the outer function may or may not be the easier part. So g of x is not x minus 6 cubed, it's x cubed. And do you see why this is the case? Well, if I were to compose again, right, f of g of x, this is the same thing as saying f, but apply g first, and then f. But then what is, oh wait, this is f of g, right? Pardon me. So sorry, I should switch the letters here. Sorry about that. The inner function is g of x, and the outer function is f. So then the outer function is f, the inner is g. So then when I apply the inner function, I'm applying x minus 6 into the function x cubed. So I'm plugging x minus 6 into this function, and then what do I get? I get x minus 6, whatever that is, I'm going to cube it. So this is exactly f of x. So that's why the decomposition of functions are these two functions. Does that make sense now? So all I'm doing is I'm taking a function that's already made in a way, and then I'm saying, hey, how can I rewrite it so I have the inner and the outer as two separate functions, so that when I combine them, when I compose them together, I get the original function. So again, this is my inner, and my outer is the whole cubing experience thing. Okay? So any questions about 18, 19?
Okay, I just like tried to write in the like the number 19, and I guess I didn't write it in the way they wanted me to.
Mhm.
So I don't know like how.
Well, I'm telling you how to for at least the one that your numbers may be different, but they want it as a comma separated list. So they want it as you plug in as a function here, and then comma the other function, and that's it. You don't have to do anything, like you don't have to put these
I'm
outer.
not supposed to put the F and the G
That's it.
in the parentheses, just the
Mhm.
function
So
itself.
you plug in the function x divided by x plus 6, comma, and then put the other function, and that's it. That's how the WebAssign wants it to be typed in or inputted. That's how they want it. It's not necessarily a common way of expressing it, but it's just for the sake of this assignment. Okay. Okay. So any other questions about the homework? Is this clearer now? Does everyone feel better about this? Okay, so if there's no other questions, let's look at the review sheet. Number 1 for exam number 1. Now, I'm not gonna go through, I can't, given the time, I'm probably not gonna be able to go through every single problem. And of course, there should be problems here that you should be able to um, try them on your own. So if you see, I've separated this into several topics. So the first topic are the fundamentals, which is basically everything we studied in the first week. These are things that I expect you to know from Math 115 or from algebra. And then the second portion of this is functions, knowing how to evaluate functions, plugging numbers to get the numerical value. You should know about piecewise functions and how to input that. That's what your second quiz was on. Then you have the difference quotient, how to find a difference quotient, finding the domain using interval notation. Then transformations is another one, graphing them, identifying what the parent functions are, writing out the transformation, sequence of transformations. And then given a parent function and given the transformation sequence of transformations, you should be able to write the final transformed graph. You should be able to add, subtract, divide, compose functions together and find a domain of each. And then finally, the inverse functions. You should be able to know how to find the inverse function and um, how to evaluate inverse functions. So we can go through any part of this review sheet here. What I want to start with though is a simplified difference quotient. I saw some problems with this on the simplifying difference quotient on the second quiz. So I want to make sure everybody's on the same page when we talk about the difference quotient. So there is a portion of you guys that were able to do this no problem, but then there's also a lot of those who found this one particularly, I guess, not as clear as what to do. So let's look at the simplified difference quotient. That's on the second page, and that's on number 2. Let's look at number 2. Number 2 says f of x is equal to 3x squared plus 2. Now, what is the difference quotient? So there's many ways to write the difference quotient. One way, I'm just going to write it as dq. So we have it as f of a plus h minus f of a all over h, right? This is what I want to see. I want to see what this is. So the first step is to find what f of a is. But f of a is very easy to get because it's just plugging in a for x. So I get 3a squared plus 2. That's f of a. The second thing I need to find is f of a plus h. What is this? This is 3 multiplied by a plus h squared plus 2. Now for this one, I want to further expand this. So then this should be 3 multiplied by a plus h times a plus h plus 2. Now, when I expand everything, right, I need to FOIL everything out, and I get a squared plus ah plus ah plus h squared plus 2. Then the ah plus the ah are 2ah, so this is 3 parentheses a squared plus 2ah plus h squared plus 2. And this equals 3. After I distribute the 3 everywhere, I get 3a squared plus 6ah plus 3h squared plus 2. Okay, and this is f of a plus h. So the important expressions here are this one here and this one here. Okay? Now, we're just setting ourselves up. Now, f of a plus h, I'm going to put this entire expression and replace f of a plus h with this entire expression here. So what is that going to look like? I'm just going to replace it. It's going to be 3a squared plus 6ah plus 3h squared plus 2. This here, this entire thing here, this is f of a plus h. And what am I doing with this? I'm subtracting the entire f of a of h with it. And f of a of h is simply 3a squared plus 2. That's f of a. And I'm dividing this all over h. Okay? And then now I'm going to distribute this negative that's in front of this polynomial. This is also known as a polynomial. And I'm going to distribute that negative. So then the next step will be 3a squared plus 6ah plus 3h squared plus 2 minus 3a squared minus 2. And all of this is being divided by h. So some of you who were able to do this, but then some of you forgot to completely cancel things out or to completely simplify. Then we realize, what do we realize? I can simplify, right? I can further combine. I could combine things. And what can I combine? Well, there's a 3a squared and a minus 3a squared. There's a positive 2 and there's a minus 2. So then all of these terms here are going to cancel out. And what's left at the end? At the end, it's 6ah plus 3h squared. And that's it. As far as what the numerator is. So in the numerator, all I have are terms in terms of h. Now what I could do is I can factor out the h in the numerator, and I get 6a plus 3h. And all of this is being divided by h. And then what happens with the h's? The h's are all canceled out. So I'm left with 6a plus 3h. And this is exactly the difference quotient. That expression at the end. So first I need to find what f of a plus h and f of a are, and I did that. F of a is replacing just x with a with x. And f of a plus h, I had to expand and simplify, expand things out and combine like terms. And then all I'm doing now is I'm plugging into this expression, and f of a plus h is this entire thing here. F of a is this little guy here. And then we distribute the negative to the second expression here, and we cancel out all the terms that could be canceled out. And then I'm left with something in the numerator that only has an h in it. I factor out the h so that the h's here can be canceled out. And the result is my difference quotient. So I just want to make sure we all are able to do this. This is an extremely important skill to do, and particularly when we speak about, for those of you who are going to continue on to calculus, particularly because this will be seen again and again, especially in the beginning of the semester when it comes to finding what the derivative is. So any questions about this particular type of question with difference quotients? So we're clear with this? Okay, I guess so. So this is simplifying difference quotients. Now, does anybody have any particular question on any of the sections that I have here on the review sheet? Section 2, functions. Are you talking about evaluating functions? Sure. So which one? 1, 2, or 3? So this is evaluating functions. So remember, the word evaluate just means to find the output given a particular input. So if you don't have any preference, then we could just look at number 1. Number 1 says, hey, I have a function, and this function is written as the following: x plus 1 over x. That's our function. And then we want to evaluate at certain input values, at particular x values. So for example, f of 2. What is f of 2? Well, I just plug in 2 every single time I see x. So the answer is going to be 2.5, or better written is 2.5. So that's what the value of the function is when I plug in 2. Now, what's the value of the function when I plug in 1/2? Same idea. Wherever I see x, I plug in 1/2. So this is 1/2 plus 1 over 1/2. But what's 1 divided by 1/2? Remember, and at this step here, I am dividing by a fraction. And when you divide by a fraction, you multiply by the reciprocal of the second fraction. So when I multiply by the reciprocal, I get 1 times 1/2. Yeah, pardon me. 1 times 2 over 1, which is just 2. So this looks very much the same way as the first evaluating of the function, because I get exactly the same thing. I just have it in reverse order. The 1/2 here is being written first, but I get the same exact result, which is 2.5. Okay, and then lastly, the last one here is in an expression. So what is f of a minus 1? Well, f of a minus 1, wherever I see x, I plug in the expression a minus 1. So what it would look like is a minus 1 plus 1 over a minus 1. And in a way, I can just leave it this way. This is the result. This is the result. I can do that, or I can say, hey, can I combine this together? I could. If I wanted to, I can rewrite this as a minus 1 over 1 plus 1 over a minus 1. Now remember, when we combine fractions, I must have the same denominator. What's the LCD here? It's just a minus 1. So I just have to multiply the top and the bottom by a minus 1 here. And I get a squared minus 2a plus 1 divided by a minus 1 plus 1 over a minus 1. And so then I can also write this as a squared minus 2a plus 2 all over a minus 1. Oops. So I can write this in 2 different ways. But the idea is that if I plug in an algebraic expression into my function, I can still do so, and the result will be an algebraic expression. So here I just went here and then I combined that into a single fraction. So I combined into a single fraction. Instead of having something added by a fraction. All right, so any questions about number one with evaluating functions? This is pretty straightforward. Evaluating can just mean plugging in. You're just learning how to plug in functions. So any questions about number one? Would you like to go over any of the other ones, number two or number three? Number three is a piecewise function. So that's something that you should be able to evaluate. And we had a question just like this in quiz number two with the piecewise functions. Okay, so if no other questions about evaluating functions, where else should we go? Where else would you like to go on this review sheet? Can we do interval notation for what? For domain of a function? So you want to do domain of a function? Okay, so let's look at finding the domain of a function using interval notation. Oh, the first on the sheet? Oh, pardon me. Oh, okay. So find interval notation. So do you have one in particular? These go really quickly. So number one, for example, right? We have sometimes we use two dots, the colon, or sometimes we use the bar x and the bar x less than or equal to 1. This is just set builder notation, right? This is what's called set builder notation. And what we're doing is we're going to rewrite the set builder notation into interval notation. And then it says graph the corresponding interval. So I think graphing it might be a little bit better to do first, so then you can get the interval pretty quickly. So if I were to graph this set is saying, hey, take all the x values such that the x values must be less than or equal to 1. So then there must be a place on the number line where there's a 1, and what we're going to do is we're going to include 1, and we're going to shade everything to the left and include 1. So then based upon this graph here, this is my graph. Now what would be the interval? The interval is everything from the left all the way to 1. So what is that? Negative infinity to 1 inclusive of 1. So that is my interval. You see that? And then this goes on, so on and so forth. So if we look at number 2, we get x such that -2 less than or equal to x, pardon me, it's not less than or equal to, it's just less than x less than or equal to 1. Now what would be the graph of this? what would be the graph? So the graph here is all the x values that are in between -2 and 1. So then I denote, I mark where -2 is, and I mark where +1 is. I'm going to open circle -2, but include +1. And then I'm gonna shade everything inside. You see that? That would be the graph. And then what would be the interval? So based upon this graph, the interval should be pretty straightforward. I should include everything from -2, not including -2, to +1, and I include +1. And therefore this is my interval. So that's 1 and 2. Those are the easier ones. So any questions about these two? Now, for example, let me just, I guess, look at number 4. And then if you want to do more of these, just let me know. If not, then we can continue on something else. So if you write this as x does not equal -4, then when you graph it, oh, Felipe, yeah, I just moved on. I skipped Felipe to number 4. If you wanted me to do number 3, I'll also do that as well. But if not, I just skipped to number 4 because number 4 is a little different. Number 4 says it isn't number 4, -4. All the x values are everything except for -4. X cannot equal -4. That's the only one that it can't equal. So if that's the case, if x cannot equal -4, but it could equal everything else, it's implied there when I say that. It's implied that x could be anything else except for -4. So that's going to be my graph. And then what would be my interval? My interval will be, can anyone tell me? What would be the interval of this graph? So I'm shading everything to the left of -4, not including -4, and shading everything to the right of -4. So then I have two different intervals. So what would be those two intervals? Right, it would be -infinity to -4, not including -4, union -4 to +infinity, and that is exactly the interval. Okay. Simplify compound fraction, please. Yes. So let me just do number 3 real quick, and then we'll move on from this. So number 3, we have x such that x is less than -6, or x is greater than or equal to 1. So first, let's graph this. So if we graph this, the x values that I care about are -6 and +1. Here, it says x is less than -6. So this means that I'm going to circle -6, but I'm going to shade everything. to the left. And then it says x is greater than or equal to 1. So then I'm going to circle 1. I'm going to shade 1. And then I'm going to shade everything to the right of 1. So then what would be my interval? I got 2 of them. So my interval here would be negative infinity to negative 6, not including negative 6, so I put a parentheses. Then I'm going to union everything from positive 1, including 1, to infinity. So this is my interval. All right? So if we're good with this, then I left you number 5 to do on your own. So now let's go to simplify fractions. Let's do simplify fractions here. Simplify compound fractions. So let's look at number 1. Number 1 has a fraction like this, x plus y over x. And all of this is divided by y plus x over y. Now, Natalia asks, the excluding of negative 6 is because it isn't also equal to, right? Yeah, that's the reason why. If it just has a less than symbol and there's no equal to symbol, then because of that, we don't include negative 6, and therefore we have parentheses. But as you can see, this case does have a equal sign underneath the the greater than symbol. So we're including 1 as well. And therefore we have the square brace. All right. No problem. So now simplify compound fractions. The goal of this is to rewrite this whole expression as a single fraction. As you can tell, I have a fraction and fractions within those fractions. So that's no good. So the first thing I want to do is I want to find the LCD. And for this guy, we can put all these over 1, right? And all we have to do is observe the smaller denominators. And 1 usually is just not really considered. It's kind of like take it for granted. And then we notice, what are the denominators? They're x and they're y. So then what's the LCD? xy. That's the first thing I have to notice. The LCD is xy. Now that I know that the LCD is equal to xy, how do I use the LCD? Does anybody remember? What do I do with the LCD once I have the LCD?
Multiply it.
Multiply the top
And
the bottom, right, by the LCD. So then let's do that. So then I'm going to put parentheses around it, to indicate that I'm going to multiply by xy, numerator, xy in the denominator. Now, when I do that, I'm going to distribute to everything inside here. So this is going to be x multiplied by, I'm just going to write this in the blue, just so you can see how this goes about. So I'm going a little bit in slow motion here. So this is y multiplied by xy plus x over y multiplied by xy. So you see this? This is after I distributed the LCD in the numerator and the LCD in the denominator. Now, what happens when I multiply y over x times xy like this? What happens is the x is here, only the x is here, they cancel out. And only the y is here, they cancel out. And then what do I have after that? X times xy becomes x squared y. Y times y becomes y squared. The denominator becomes x y squared plus x squared. So do you see how I cleared the denominators? So I cleared smaller denominators by multiplying the LCD. So once I'm able to do that, I can factor out the y and the x if possible. In the numerator, I get x squared plus 1. And in the denominator, I get x over y squared plus 1. But I noticed that I can't really do anything else. So therefore, I leave it. And that's my final answer. So I was able to simplify the top compound fraction into a single fraction. So is that clear? Any questions about number 1? Any questions about number 2, number 3? So, you know, most of these sections that I have here of for each section, I have, you know, sometimes I have 3 problems, I have 4 problems, sometimes I have 5 problems. And the general trend is that they get progressively harder as you move along those sections. So like the latter half of the questions at the end of each little subsection, they're usually the harder ones. But again, the idea behind simplifying compound fractions is the same for every single one. Find the LCD, multiply the top and bottom, distribute, cancel out, simplify, factor if needed, and that's usually how it goes for this. Okay. Okay, next. So Tanzila says, finding the domain. Yeah, we can definitely do that. Finding domain of functions. And we're going to do so algebraically. So if we want to find a domain of a function, we can choose any one of these functions. Let's do number 3. So look at number 3. I got f of x is equal to the square root of x plus 2. And I'm going to divide this by 3 minus x. Okay, so this is we have to take a little bit of care to see what kind of functions I have in the numerator and in the denominator. Now remember, when we have functions and we have a denominator, the denominator can never be 0. So that's the first observation, right? This can never be 0. If it were equal to 0 in the denominator, we would have an undefined function. So whatever makes the denominator equal to 0, that x value would not be part of the domain. And hopefully you see that this is actually pretty easy to solve. So we're looking for the x values that are not good. So these x values will not be in the domain. And if I subtract by 3 on both sides, I get negative x equals negative 3. So then I get x is equal to 3. But what does this mean? this x value is not in domain. So this is not in domain. So I know for a fact that x cannot be 3. I know for a fact. Because of my denominator. So this comes from my denominator. Now let's look at the numerator. What does the numerator say? The numerator is a square root function. And what do we know about square root functions? Any square root function, the expression underneath the radical must always be greater than or equal to 0. So we know for a fact that this guy inside here, x plus 2 greater than or equal to 0, it must be, right? It must be greater than or equal to 0. So x, when you solve for it, must be greater than or equal to negative 2. So the denominator gives me the fact that x can never be 3. And the numerator tells me that x has to be greater than or equal to negative 2. Because this has to be both true at the same time, let's see what that looks like when I graph it. So graphing it will give me a good idea as to what the domain will look like. So somewhere there's a 3, right? There's a 3 somewhere, and there's a negative 2 somewhere here. What is this saying? X could be anything equal to, greater than, or equal to negative 2. So I can include negative 2. I can shade. But what's going to be the problem? It can't be 3. So then I'm going to shade everything up until 3, skip 3, but still shade because x is greater than negative 2. Now, what would be my domain? Well, my domain is exactly what's expressed in the graph. I'm just going to express the domain as an interval. And you see how these things build upon what we just did in the beginning, or what's in the beginning of this review sheet, interval notation. That's why we care about interval notation, because now we're using interval notation not just to express some random set. Now we're using interval notation to express the domain of functions. So then what would be my first interval? It would be include negative 2, comma, 3, open circle, union, 3, all the way to infinity. This is my domain. So any questions? Any questions about this particular problem? Do you want to do more of these? Is it clear as to how we combine the denominator and the numerator together to find the graph on the number line, and therefore to find the interval notation? So are we clear with this? Number 3, we're good with this? Yes. Okay, good. Is there any other questions on this section here in terms of finding the domain? If not, then we can move on to something else. Factoring number 3 and 5. So factoring completely. Okay. So if we're at the factoring section here, let's look at number 3. Whoops. Number 3. So I have 4x cubed minus 8x squared plus 3x minus 6. So I want to factor this, right? What I notice first is that I have 4 terms. Whenever I have 4 terms, the first thing that should pop in your head is factoring by grouping. So let's look at what happens if I were to factor by grouping. Remember, we need to group them, we need 2 terms. So this is when you have 4 terms. This doesn't always work because not every time you have 4 terms are you able to apply factor by grouping. But if you do have 4 terms, it's good to try to see if it's possible. So the first group, 4x cubed minus 8x cubed, I can factor out a 2x squared. And then what's left? I'm left with an x minus 2. And then in the second group, 3x minus 6, I can factor out a 3, and I get x minus 2. Now what happens? I can factor out an x minus 2 in both of these expressions. So I can factor an x minus 2 out, and I'm left with 2x squared plus 3. And therefore, I am done. That is the factorization of the number 3. Oh, pardon me. I see. Thank you. Thank you, guys. Sometimes a little bit too early in the morning. So this is 4x squared. You're right. It's 4x squared. Because you guys are right. 2 times 2 is 4. Thank you for that. And then this becomes 4. So you guys are right. For number 3. So are we clear with that in terms of understanding why we factor by grouping? Because we have 4 terms. So whenever you have 4 terms, you can attempt to factor by grouping. It doesn't always work, but in this case, it does. Okay, so that's number 3. And then let's look at number 5. Number 5 is, it looks more complicated. X minus 1, parentheses, x plus 2, squared minus x minus 1, squared, x plus 2. So some of you may be tempted, I'm not sure, to maybe expand everything out, like take this and square that, and then expand that by multiplying by x minus 1, and doing the same thing with this. But remember, when we factor, we should always see if we can factor by GCF. That's usually the first order of business. If we can't do that, then we look at the next thing. It could be difference of perfect squares. It could be a trinomial. It could imply factor by grouping. But the first kind of factorization, the simplest kind, is GCF. Now, if you notice, there's certain things about these 2 terms that are similar. They both have an x minus 1, and they both have an x plus 2. So it is very tempting to say, that the GCF is x minus 1, x plus 2. This is my GCF. What that means is I can factor out this GCF from each of these 2 terms. This is one term, this is second term. If I factor out this GCF from this, what is left over? So there's going to be a bit more of parentheses here. What's left over when I factor out an x minus 1 and when I factor out an x plus 2? Well, what's left over is the x plus 2. Do you see that? And then if I factor out an x minus 1 here and an x plus 2 here, what's left? X minus 1. Does everybody see that? So then I got x minus 1, parentheses, x plus 2, And then here I can further simplify this, right? I can subtract an x and then remember, when I distribute this -1, I subtract an x and add a 1. So this is going to look like this. X plus 2 minus x plus 1. And then I can get rid of these parentheses. And this is x plus 2. The x's here cancel. And the 2, and you add the 1. So what I get at the end is I get that x minus 1, parentheses x plus 2, multiplied by 3. Or in other words, 3 times x minus 1 times x plus 2. So this is my factored form. Why was there a plus 1? Well, the plus 1, remember, comes from the fact that I'm subtracting by x minus 1. If I subtract by x minus 1, then I'm going to distribute that -1, and this becomes negative x plus 1. Yeah, negative times a negative is a positive. That's why. No problem. Like I said, another way you could have done this is to expand everything out, and then combine, and then factor. But it's always good to observe first if there is a GCF. And the GCF is exactly what's in common in both of these expressions. It's just that when I factor out the GCF, I'm left with the x plus 2 in the first term, and I'm left with an x minus 1 in the second term. And so therefore, when I continue with the combining like terms here, I'm only left with the 3. And this is already factored for me, so I'm good. Okay. Equation of the circle number 5. Yes, we can do everything. Let's do everything at once. Okay, so then the next one is equations of a circle. So number 5. So the center that we're given is -1, 4, and the radius is equal to 2 rad 2. Now, what's the equation of a circle? What's the equation of a circle? It's x minus h parentheses squared plus y minus k squared equals r squared. Well, I have my h, and I have my k, and I have my r. So all I have to do is plug in. So this becomes x minus -1 parentheses squared plus y minus 4 squared equals 2 rad 2 squared. X minus -1 is x plus 1 squared plus y minus 4 squared. And 2 rad 2 squared is, if you do 2 squared, it's 4. Rad 2 squared is 2. 4 times 2 is 8. So this is 8. And that's it. That's going to be the equation. X plus 1 squared plus y minus 4 squared equals 8. So the key here is to understand what the equation of a circle is. If you know this, then this question should not be too difficult. Okay, so let's look at number 3, transformations. Question number 3. So that's a good one. So we have to be able to identify transformations of graphs of functions and the parent functions, transformations. So let's look at number 3. F of x is what? Negative absolute value of x plus 5 minus 3. Okay, so then the first thing I should immediately notice is that I have an absolute value. And the parent function, so part A, what is the parent function? Remember, one of the parent functions is the absolute value function. So the absolute value function would be the appropriate parent function for this. So I'm applying transformations to this parent function. Okay, part B. Part B, it says apply transformations. So what are the transformations? How do I identify the transformations? I must look at the algebraic commands. So I look at my function here, and what do I notice? I have a negative in front of the absolute value. I have a plus 5 next to the x, and I have a minus 3 outside of the absolute value function. So who can tell me what are the transformations that I have applied here? So correct. So Chen, number 1, first step. This here is number 1. I'm going to reflect across the x-axis because the negative in front tells me to do so. So reflect across the x-axis. Step number 1. Step number 2 would be what? That plus 5. What does that plus 5 indicate when I add it to the x? I move to the left by 5 units. Very good. So then I move, or I should say horizontally shift. Horizontal shift 4 units to the left. Sorry, pardon me, 5 units. 5 units to the left. And then finally, that minus 3 indicates a what? It's a vertical shift down by 3 units. Right? And those are it. Those are my transformations. And then it says sketch the graph of the function. So I'm going to sketch it. So part C is sketch. So when I sketch this, what is the difference between absolute value of x and, so what is the difference between this versus this? Well, this means absolute value. This doesn't really mean much. It's just, you're just putting parentheses around x. Did you mean to say f of x? What's the difference between that? Okay, so f of x, that just means that this is a function. This is saying y is a function called f. This is saying y is the absolute value is the absolute value function. So the difference is that this is a specific type of function. This is some random general function. So this is notation for function. This is a particular function. Do you see the difference? No problem. So this is x and y, right? Now, what's always good to do is to always draw the original function, just to give you an idea of what you're starting with. So this is my original function, right? This is y equals absolute value of x. This is it. This is the graph of y equals absolute value of x. Then what happens? Let me apply the transformations. Then what happens? I reflect, right? I'm just gonna put this as a dotted line. I reflect. Whatever I had here, I reflected. That's number one. That's number one. Number two, what happens after that? It says a horizontal shift to the left by 5 units. So I use -5, right? And now this is my shift to the left. So my graph now goes from 1 to 2. And then after that, what do? I vertically shift down by 3 units. So 3 units. So 1, 2, -3. I shifted down by 3 units. So then this should be the final graph, or at least a sketch. So if I draw these lines here, arrows here, and I got arrows here. So this is going to be the function f of x, right? F of x is negative absolute value of x plus 5 minus 3. Do you see that? Do you see how we started with the parent function, and then we applied course in the right order of the transformations, the sequence? I take this, reflect, shift to the left, and then shift downward. When I put, it says it cannot be graded. I don't know why. Yeah, I don't know. Chen, which one are you? Are you talking about which question? Number 5? Question number 5? You just have to be careful sometimes with how you write it inside the homework. Let me just hold on. Because web assignment can be a little bit tricky and very, very particular in how they want it. Let me just check out number 5 really quick. So Chen, it says to move to the left by 5 units and move downward by 3 units. Huh. So that is interesting. That it marks it wrong. You said it marks it wrong? It could just be a type input issue. Let me just take a look. Are you sure it's 5 units down or 3 units down? Because it says, I think it says 7 units down. Yeah, it's a different number. Yeah, it's a different number. It says 7 units down. And you have to put the absolute value around the x plus 3. So I'm not sure if you did that. So you should try that. So the absolute value, you have to put the symbols for the absolute value. And then it's -7 for you, I think for you. Okay? So try that. All right, anything else? You should be able to put the absolute value. Let me just, you should be able to. When you, the moment you type in, I'm not sure if you notice, but if you type in on the right, certain things, like there's a calc pad. Yeah, you are allowed to put it. If you look at the calc pad, there's an absolute value function. Let me open it up and let me show you. I'm not sure why you're having trouble with this, but you have every capability of doing so. So let me share my screen. So if you look at the homework, so this is just like a random one, right? For number 5, if I type in, if I just want to input, you see how we have here the calc pad? So if you go to the functions portion here, this is absolute value. Boom. And then you have the absolute value. And then you say this is x minus 6. And then you, I think you click this. Yeah. And then this becomes minus 7. So that's the way to do it. You have to use that thing on the right. So on the right, it has a calc pad, and you have many other things you can do with this. You have all these different. You even have the Greek alphabet. So you have a whole bunch of an assortment of things. So make sure you use this to your advantage. If they're asking you for absolute value, there should be a way to write it, and so use the functions. Okay, the functions thing. I think they call palettes here. All right. So for those of you who didn't know that either, you can use this for your inputs of your answer choices for homework. All right. Okay. So anything else?
Yes. Can we look at one of the find the domain of each, where it gives us f of x and g of x?
Yeah, sure. Let's look at that. So find the domain of each.
Can we start with not 1 though? Like, can we do like number 2 or 3?
Yeah, no problem. So let's look at number 2. So find a domain of each, right? Part B. It's number 2. So f of x is 1 over x, and g of x is equal to 2x plus 4. So the idea is I want to apply all the operations in part A and find a domain of each. So for 1, for example, right, I want to find all of these. I want to find what is f plus g. So I can call this A. What is f of g? F plus g. Well, remember, it's f of x plus g of x. So this is going to be 1 over x plus 2x plus 4. And that's it. That's my function. It's a little weird, but that's what it is. Now, what would be my domain of this function that I just combined by adding? Well, I have to first understand what's the domain of f and then understand what's the domain of g. Well, g of x, right? What is g of x? This is a linear function. Any x value works. So the domain for this function is, all real numbers. Now, what's the domain of the first function? Well, the first function, if you notice, it's 1 over x. X can never be 0. So it's everything that's not 0. So then what's the domain? Negative infinity to 0, union 0 to infinity. Now I'm combining both of those functions into one single function by adding them. So when I added them, I'm going to combine the domains as well. So then what's going to be my domain for this combined function? It's going to be negative infinity to 0, union 0 to infinity. Do you see that? Because here, all the x values are good for this. I can plug in any x value. I'm good. The problem is I can't do that for this. And the only issue I have is the 0. So I can include everything except for 0. So that's part A. And then I keep on continuing with this, right? I do f minus g. What is f minus g? So this gets kind of repetitive here. F of x minus g of x. So this becomes 1 over x minus parentheses. Make sure you put this parentheses around the 2x plus 4. Distribute the negative and I get 1 over x minus 2x minus 4. That's f minus g of x. And then similarly, the domain is exactly the same. The domain here is nothing out of the world, out of this world. It's the same exact thing because I have a very similar function, except that here it's all summed up, and here we have subtraction symbols. So that's f plus g, that's f minus g. So let me put this here, and then the next thing I have is what? Fg, multiplication. So when I multiply this, what do I get? I get, so fg of x is f of x times g of x. What is f of x? It's 1 over x. What's g of x? It's 2x plus 4. So then when you multiply this, you get 2x plus 4 over x. And that's my function. This is my function, 2x plus 4 over x. What's my domain, though? My domain, remember, I can't have anything in the denominator being 0. So x cannot be 0, but it could be anything else. And so this is how we're going to carry on with all of these. And then next one is f over g. What does that mean? This is f of x divided by g of x. What is f of x? It's 1 over x. What's g of x? It's 2x plus 4. Well, of course, I'm not going to leave it this way because I have 1 over x divided by 2x plus 4. You can write this over 1. And why do I write this over 1? Is because I'm going to, when I divide it by a fraction, I must multiply it by the reciprocal. And so then this is my function, 1 over x. It's going to be 1 over x multiplied by 2x plus 4. That is my, this is my division. Now, what's my domain? Can you tell me what the domain would be? Good. It can't equal 0. My denominator cannot equal 0. But if you notice, look what I have this time. I also have a 2x plus 4 that can't equal 0. So then if I solve for 0, what do I get? I get x equals 0, and I get x equals negative 2. So actually, I get 2 x values that are no good. So this can't happen, and this can't happen. So if that can happen, then let me just draw on the number line so I can give you a better understanding of this. I don't have 0 and I don't have negative 2. So these don't work. But everything else does. So everything here good, everything in here good, and everything out here good. So then what would be my domain? My domain would be negative infinity to negative 2, union. Negative 2 to 0, union. 0 to infinity. And this would be my domain. The reason why it's negative 2 is because when you solve 2x plus 4, I'm pretty sure, right? When you solve it, subtract by negative 4, right? You get 2x equals negative 4 and you divide by 2, you get x equals negative 2. Because it's negative 2 times, it's 2 times negative 2, which is negative 4 plus 4, which is equal to 0. Right? So this is my domain. Okay, and then one last one of these. So we've done all the combinations in terms of addition, subtraction, multiplication, and division. And then the next 4 are compositions. So if you do f of g of x, right? What are we applying first? We're applying first g of x into f of x. But what is g of x? G of x is what? 2x plus 4. So this is plugging in 2x plus 4 into my function 1 over x. So I get 1 over 2x plus 4. This is what I get. Now remember, I'm applying g of x first, and then I'm considering what are the x values of this function. Can I plug in any x value into this? What's the issue? The issue again is that this cannot be 0. But we just showed how the denominator can equal 0. It can equal 0 if x equals negative 2. So that's the bad point. That's the bad point. And is there any other point here that's bad? That's the only point. That's the only point that's bad. The only bad point is if this becomes 0 at all. And of course it can, and that's when x equals negative 2. So x cannot equal negative 2. So then my domain, so this is let me just write this over here. So f follows g of x is going to be the function 1 over 2x plus 4. And my domain is everything that's not negative 2. So negative infinity to negative 2, union negative 2 to infinity. All right. Okay, guys. So